Welcome to CS420, lecture number 9. I want to start this lecture by making the distinction between variable declarations and variable references. Variable declarations are when we declare that we want a new variable. It's when we create it. Variable references are when we use the variable. So there are three ways that we know in Racket to define new variables. One is with a define, one is with a let, and the other way is by creating a function that takes in parameters. So each one of these ways is a way to create a new variable, and the creation is called a variable declaration. Now in Java, you know variable declarations by putting the type and the name of the variable. In Racket, we do not have to declare the type of the variable when we declare a new variable. Now let's talk about variable references. I've added in here two new x's. These x's are different than declaring a new variable. In this case, we are using the variable. And by using, we want to look up the variable and find out its value. In this case, this x, if you see the little arrow, it actually points to the variable declaration of where it's declared. This is something that Dr. Racket does. So this x is bound to 5. So when we use the variable, we look up x, find that it's equal to 5, and then add 1 to it. So this will return 6. Now this is the same variable declaration inside of the body of a lambda. And if you notice, the arrow comes from here. So this is the variable declaration, and this is the variable reference. Now we can also just put a variable on a line, and in that case, it's referring to this define, the variable that we declared in the define up here. So when we use a define, we make our variables global. Let and lambda mean that the variables are local, meaning we can only use them inside of their bodies. Now we've talked about static versus dynamic before when we talked about typing. And if you remember, I said in this class, whenever we say static, it means that the property is determined at compile time, or when you're typing your code. And versus dynamic is the property is determined at runtime as the program's running. So I before said this x is global and these x's are local variables. And that is referred to the scope of a variable. The scope of a variable is where you can use that variable. If I change the names of these to be a different name than the others, in this case right here, x can be used anywhere in our program and anywhere down here. C can only be used inside of this body of the let. And R can only be used inside of that body of the let. That is the scope of the variable. Now, we can determine that because Racket is statically scoped. What that means is we always know, just by looking at our code, without running it, just by looking at our code, we can always tell where the variable declaration is. So here's a variable reference. We know where the declaration occurred. Here's another variable reference. We know where the variable declaration occurred. Now, a dynamically scoped language, we wouldn't know. So let me put up an example in Java that shows the difference between static scoping versus dynamic scoping. All right, so we have a main function that declares two variables, x and y. And notice this is the declaration, and all the other times we see x and y are variable references. So we make x equal to 4. We call this function foo, and let's not look at foo right now. You can see it, but let's pretend we don't even look at foo. Next, we say y is equal to x plus 1. So x is equal to 4, so 4 plus 1 should be 5. All right. So that's if we're using static scoping. This x refers to the x right there. We can tell that by just looking at this main function. Now, if we're doing dynamic scoping, we look at foo and we declare a new x variable that's assigned to be 3. So if we were to run this code, x is now 3, and when we look up x back in main, then x is now 3 and y would be equal to 4. So in static scoping, we know that this x refers to this variable declaration. Now with dynamic scoping, this variable now refers to the new declaration that happened when we were inside of foo. Now, this is a very simple example, but this could get more complex. Let's say that there's another function called bar, and I end up calling bar. And inside a bar is an if statement that decides if it wants to call foo or some other method. And so we don't know if foo is going to get called or not. We have to run the program to figure out if a new variable called x gets declared to figure out which variable that x is assigned to. As you can see, dynamic scoping can get really confusing for the programmer. And in fact, so confusing, I don't know a single language that does use dynamic scope. They all use static scoping. Now later on in this class, we're going to implement an interpreter, and you'll see in order to implement static scoping is going to create us a little bit more work. We have to be able to add new variables whenever we see a declaration, but then we have to remove the variables whenever that declaration goes out of scope so that we can use static scoping. Now I have right here a simplified BNF of the grammar of Racket. If you notice, we have a way to create functions where we declare a new variable. We have a way to call functions where we put a function here and the parameter here. And we have a way to refer to variables that we've declared. So this is a variable reference. This is a variable declaration. And we can create lambda expressions that follow this BNF. Now it's a very simplified version of Racket, but we can use that to figure out whenever we have a variable reference where its declaration is. And that's lexical addressing, is whenever we have a variable reference somewhere, we want to know where the variable declaration is so we can figure out its value. Now I have one of these lambda expressions, and just to verify that it is a lambda expression, I put the syntactic derivation up here. So we start off with an expression, so we can replace an expression with this. By the way, I'm going to call this an application expression. It's when we call a function. So this is an application expression, and it has two expressions inside of it. So I'm going to replace the first expression with a lambda expression. So we'll call this one a lambda expression. And a lambda expression has a symbol with another expression for its body. And I just left this expression alone. Next, I replace this symbol with x. And now I replace this expression with a symbol expression, or this first option right here. So we'll call this a reference expression, because this is where we refer to variables that have been declared. So this is a reference expression or a symbol. I also replace this expression with this symbol as well. Next, I replace this symbol with x, just like I replaced this symbol with x. And I replace this symbol with y, and I'm left with this. So this is a expression or a lambda expression that we have from this BNF. Now if we look at this, remember this is where we declare variables inside of a lambda, and this is where we refer to variables. So if we look at this expression, this is a variable declaration, and these two are variable references. And when we do lexical addressing, we want to know where this variable was declared. So this variable was declared right here. What about this y? Well, there is no y declaration, so this variable isn't bound to anything. So we call this variable bound because we can tell that it's been bound to a declaration, and we call this variable free. So one exercise you'd want to do is to be able to look at one of these lambda expressions, pick out the declarations versus the references, and then figure out where each reference, where its declaration is. So this one is bound and this one is free. So that's one exercise, is determining if they're bound or free. Now this would obviously crash unless y was bound to some global variable. Now let's look at a more complicated example. We have a lambda whose body is a application expression who has a lambda inside of it. So one exercise I'll leave for you to do is maybe to do a syntactic derivation of this expression right here. That would be a good exercise, help you see everything that's going on. But the exercise I will do with you is figuring out each variable reference and if it is either bound or free. So let's look right here. This is the body, everything that's highlighted is the body of this lambda expression. That's the scope of the variables x and y. So this x is obviously bound here, and this x, or this y, is obviously bound to him. Now we have another lambda, and this is his body that declares a, so a is bound to him. So all of these variables are bound variables. Now remember, in this case, this y is a free variable. So next we want to connect the variables references with their declaration. And you can see that this example came from your lecture note, and this is how we're connecting it to its declaration. Notice here's the x refers to this x, this a refers to that a, and this y is that y. And we have two numbers here. The first number is how many scope blocks do I have to go up to get to my declaration? Because this lambda introduces a new scope block, we have to go past it to here. And that's why this is 1. So we go to this lambda, x isn't in there, then we go to the lambda outside and we find x. Now this next is the position of where x is, and as computer scientists we always start counting with 0. So x is in the 0 position. So this x is bound to that. Now what about this a? So a, we don't go any scope, is in the current scope block. The a was declared, this is inside of the body of that lambda, so we don't go up any, and of course it's in the 0th position, and so that's why we do 0, 0. Now y, right here, we have to go up 1 scope block and over 1, and now that's y's position. Finally, we have this x. We've exited the body of a, and we're back into this scope block right here. So we don't have to go up any scope blocks with this x here, and it's in the first position. So that's why this is 0. And just to repeat, why is this 0? Well, because we left this scope block, so x is in the current scope. Versus this one, this x is inside of this lambda that declares a, so we have to go up 1 scope block to get to the x here. So that's lexical addressing.